Hello everyone, welcome back to the lesson of building AR model from the scratch. So in the previous lesson I discussed about the theory behind the autoregressive model. In this lesson I'll be showing all of you how you can build the autoregressive model in Excel. So let us get started. So first we need to split our data into two parts. One is training data and testing data. So 80% of the data we can roughly take for the training purposes, which I have already taken. Let us assume this is the training data, and yeah, let us create the lag 1. So lag 1, lag 2 and lag 3. So what is lag 1? Lag 1 is you lag the data by one first period. Lag 2 you lag it by 2 periods, and lag 3 you lag it by 3 periods. So this is what the lag 1 2 3 are. Once done with this, we need to remove these 3 rows because these are the blank points. We can't use them. So generally it's recommended to remove them, or you can try to replace this data by forecasting these points as well based upon the past data if you have it. But yeah, the best way is to remove them. So instead of removing it here, I'll keep our data here as it is and go to practices to uh, take the same data separately. Okay, now since we are removing these ones, we won't be able to use these ones, so we'll take these data points. Okay, so yeah, let me just set the format right. The date. Perfect. Now you have the data ready. You have your sales and you have lag 1 2 3. So in autoregressive model, as we discussed in the theory, what we discussed, here's the formula. We try to relate the prediction by the past data, t minus 1, t minus 2. So these are called lags. So here we are. So we will be relating 58. So 58 by the previous two lags, which is 21, 51, 42. These three lags. And similarly 175 will be related with uh, 58, 21 and 20, 58, 21 and 51. So here are these 3 points. So once you have them ready here, we just need to select them, go to data, go to data analysis, and here you can select the regression. Click OK. Once you have the regression ready. So y, what is y? So y are all the points with the help of which we are going to, sorry, y is the demand which we are trying to predict here, and x are the all the inputs which we are giving to them, which are lag 1 2 3. So since we had labels, we'll be selecting the labels. We want output into the new worksheet. Let's have the residuals as well and just hit OK. Here we go. Now you have the output ready. Now we need to understand this statistical output, what it is. So if you go here we are. So this is the output which we have got from AR model, and the model has given different statistical parameters based on which we need to judge whether the output which has come, whether it is useful or not. So let us get started one by one. So first is multiple R. Multiple R, this is the parameter. Yeah, this is the output given. So What is multiple R? This is the correlation coefficient. It tells you how strong the linear relationship is. So it has to be as much as closer to 1. So if we go to our output as this 0.88, which is a good one. So based on this we can say, okay, the output is good. Now let's go to the r square. So r square is nothing but the square of this, or in other other terms, multiple r is square root of r square. So what does it tells? It tells how many points fall on the regression line. So since we'll be plotting a forecasting line, or uh, the model which is created by this one, the linear line which has been created by this model, how many data points lie on it. So suppose the value is 0.8, so which means 0.8% or 80% of the values are on the line, and 20% will not fall on the line. So we go to our output, so it is 0.78. So 0.78 means it's a good one, so 80% of the accuracy we can expect. And then there is adjusted r square. What is adjusted r? Adjusted r is basically, it will give you an idea based upon how many variables you are using. So here in this case, if you see how many variables we have used 3 variables. So if you increase the variables, number of variables 1 2 3 4 5 6, so this will take an account for that also, and it will penalize when you use more and more variables, so more and more lags when you use. Okay, so adjusted R is also good. Standard error is how much error we have. So 145 error has come. So what does this mean? So if you go to our model, so here if you see the values are 671 616 781. So we can expect an error of how much quantity? 145. So this is an estimated error which can come when you try to predict these demands. Okay, now what is the next one? Then there is observation. So this observation this observation tells the observations which you have used for predicting the model, so which is 90. So this is nothing but the number of observations, which is these. So 19 observations we have taken. Perfect. Now next is the significance f value. This is the p value associated with the overall model what we have. So this now next is the p value, which helps how much significant the variable is and how much explanatory it is. Now coming back to our, yeah, now here we have different p values. You see p values, so this p value helps us understand the particular variable which you have taken, how much it is statistically significant, and how much we can use them in our model, or how much it is helping actually predicting the future forecast. So how we can judge them? If this p value is less than 0.05, so which is in these two cases, if you see these two cases, they are less than 0.05. But if you see lag 2, uh, it's way above 0.05, which means it's not so much adding value, which is not so much statistically significant in our equation of linear equation of autoregressive model. So it's preferable that you remove this one and predict the model again. So we need certain number of iterations when you are building such models. So lag 2, from this we understood what it's happening, that it's not so much significant. So we need to remove the lag 2 and predict the model again. So let's go again. Let's give this name as AR iteration 1. So you need to go to the model again, take your data, and now this time we need to remove the lag 2. We only need lag 1 and 3. So here we taken this data, we won't be taking lag 2, I'll repeat why. Because in the output we realize the p value which has to be less than 0.05, and for lag 2 it is higher, so we'll be removing the lag 2. So let us take it, paste it, and we just remove it. Here we go. Now again, what you do, again you follow the same process. go to data, go to data analysis, regression. Now the y remains same, which is this one, but still, since we have changed the sheet, I'll input the data again, and the sorry, I mistakenly input the months. You take the demand as predictable variable, and the x will be lag 1 and 3. Repeat the same process again. We have label, we have worksheet, and hit OK. So again the output has come. So this is output of iteration 1. Okay, now this time we'd like to see if our p values are improved. So here we go. So these are the p values. So we have good p values compared to the previous output which we had for the model. So here we had one variable which was not adding any significant value in terms of prediction because the value was above 0.05. So we removed it and we did the iteration 1, and here in this case we have the output as improved p-value. So here the p-values are close to 0.05, so we can use it. And again, if you go through the R values, they are also good, so they are around 80%. So 80% of the time we can expect the forecast is going to be good, which is a good model, which is a good forecast. Now how do you set the equation? Now the demand to be predicted would be equal to coefficient plus lag 1 into this, lag 2 into this. So these are our most important values, so we'll just copy them, bring it here, or maybe here into our original model. I'll just bring them, paste it here. So these are the final values which we'll be using to predict. Now I may remove this data which don't need it anymore. Now if you want to predict the November data, so what will be November data based on this? This would be intercept. So let me bring the formula again so that it's easy for you to relate. So here is the formula coming here. So I'm pasting the formula again so that it's easy for you to understand. So xt, so this which we are trying to predict, you take equal to. So actually we need to split the data into two parts, training and testing data. First test it for the testing data, then apply it for the uh, future predictions. But here, to keep it simple, not to make it complicated, since it's already complicated to follow so many steps, I'm directly predicting it, skipping that step of testing training data. Maybe I'll cover that into a different lesson. But yeah, now what would be the prediction value? It would be the b naught. So b naught is nothing but the intercept, so this one, plus this would be coefficient of lag 1 into let us take the coefficient would be D27. Yeah, this is the coefficient 1, plus now we have taken the lag 3 directly because lag 2 was not a significant coefficient, the p value was higher than that, so we'll skip the b2. So anyway that was not adding enough value, so we have removed it, and we'll be taking directly b3. So b3 would be this coefficient into the lag 3, which is this one. Here completes our. So this is the prediction for the November. The same way you can predict for December, Jan, Feb going ahead. So here is our final prediction for the November month. So here comes our output. Then based on this, you can calculate your accuracy, bias, and judge how good the model is. But yeah, this is what it is, the AR model in a nutshell, how you can build it in the Excel sheet by using the regression option in the data and taking the lags of the same time series data. So hope you got it. I'll be sharing this Excel sheet for you to practice it as well, and so that you develop confidence to uh, build the model on your. So thank you. That's it. What I had for this lesson, and have a great day ahead.